Good morning, everybody. Hope you're all healthy and safe. So, we shall be continuing, or we shall be moving on to the next section. So, in the previous section, we had discussed what is meant by a separable differential equation, and we had seen how to solve that. So, in this section, that is section 2.3, we are going to discuss about linear differential equations. Okay. So differential equations which are linear, we shall be seeing the definition, then we shall see the method how to solve them. So let us see what is meant by linear equation or linear differential equation of first order. A first order differential equation of the form a1 of x into dy by dx plus a dot of x into y is equal to g of x is said to be a linear equation in the dependent variable y. Okay, so this is linear because it does not have any other, there is no coefficient which affects the linearity of this differential equation. So first we have to consider a first order differential equation, and the general form of the linear differential equation first order is of this form, that is a1 of x into dy by dx plus a dot of x into y equal to g of x. Okay, so keep this in mind. This is the general form. So if you are given any differential equation and if you can see that it is in this linear form, then you can know how to solve the differential equation, which we will be discussing in today's lecture. Now there are two types of linear equations. That is, first is when g of x is 0. When g of x is 0, we call it to be a homogeneous equation, and otherwise it is said to be a non-homogeneous equation. Okay, so I hope it is clear. G of x equal to 0 means the equation is said to be homogeneous, and if it is non-zero, it is said to be non-homogeneous. Now let's move on to the standard form. That is, just look at what the equation, differential equation, first order differential equation. It is a1 of x into dy by dx plus a dot of x into y is equal to g of x, right? So if I divide this whole differential equation by a1 of x, what do I get? I get dy by dx plus a dot of x divided by a1 of x equal to g of x divided by a1 of x. Okay, dividing both the sides by a1 of x. So I'm going to call this particular function, that is a dot of x by a1 of x by p of x, some p of x, and g of x by a1 of x by some other function, say f of x. So I get this is the standard form. This is very useful. This is the form that we'll be using most often to solve the differential equation. So here p of x is nothing but a dot of x by a1 of x. So we have to keep in mind that a1 of x must be non-zero, and g of x will be equal, not g of x, f of x. F of x will be equal to, it will be equal to g of x by a1 of x, right? So this is the standard form. So this form we'll be using more often. That is, whenever we are given any differential, any linear differential equation, what we do is we convert it into the standard form, and after converting it into the standard form, we can easily solve the particular differential equation. So let's see what is the method of solving this particular differential equation. So you can see in your textbook the differential equation, linear differential equation, the definition is given, which we have just now seen. And now I would like to discuss a small property about this, that is regarding the solution of this differential equation. Okay, that is, all the solution of this particular differential equation will be of the form y is equal to yc plus yp. Okay, where yc is nothing but the solution of the corresponding homogeneous equation. So if you are given any linear differential equation, that is dy by dx plus p of x y is equal to f of x. So if I put f of x as 0, I get that differential equation to be homogeneous. So yc is the solution that we get when we solve the homogeneous differential equation, and yp is the a particular solution of the non-homogeneous equation. Okay, so this is how we can see if y is equal to yc plus yp. Okay, where yc is a solution of the associated homogeneous equation, which is the associated homogeneous equation dy by dx plus p of x y is equal to 0, right? And yp is a particular solution of the non-homogeneous equation. So you can see if we substitute, instead of y, if I put yc plus yp, you can see the differential equation becomes d by dx of yc plus yp plus p of x into y, right? Instead of y, yc plus yp. We'll see whether this is f of x. So this is actually f of x itself. Why? Because if we combine the yc terms common, actually yc is a solution of this, right? So instead of y, if I put yc, this will be satisfied. This equation has to be satisfied. So dyc by dx plus p of x yc will actually be 0, and this is nothing but f of x. Okay, so it's just that the solution of this linear differential equation can be considered as a sum of two solutions. One is of the non-homogeneous part and associated non-homogeneous equation, and the other is the associated homogeneous equation. Okay, that's it. Now if you look at the homogeneous differential equation, okay, the homogeneous differential equation is must be familiar to you. Why? Because it is a separable form, right? You can separate it. You can see it's given. The homogeneous differential equation can be written as, it is actually dy by dx plus p of x y is equal to 0. So if I am dividing by y, p of x by y, so I get, or if I take this to the right hand side and divide by y, so I get that dy by y plus p of x into dx will be equal to 0. So it is variable separable. Right? Now we know how to solve the variable separable differential equation. You just have to integrate it. So solving this, we get the solution to be c into e raised to minus integral p of x dx. Okay, so the particular solution is actually y is equal to the solution, not the particular solution, sorry, the solution of the homogeneous equation is actually yc is equal to c into e raised to minus integral p of x dx. Okay, now we will be using this particular solution, that is the solution of the homogeneous one, to find the particular solution yp. We will be using yc to determine yp. Okay, so the method, the derivation is given. I'm not moving on to it. I'll just move on to the method, how to solve the differential equation. This is simple. You just can go through the derivation. So here, if you look at it, we have if I put e raised to minus integral p of x dx to be y1. Okay, so yc is nothing but c into y1. Similarly, instead of c, which is a constant, if I put some variable, that is some variation, some parameter u of x, that will be the particular solution. Yp will be equal to u into y1 will be the particular solution. Okay, so I will not make things more complicated, and I will not the derivation part and the other form can be you just can refer the textbook and see how it is. I'll just give you the gist of the method of the solution, how to solve a particular linear differential equation which is in the standard form. So first of all, whatever differential equation is given to us, write it in the standard form, that is dy by dx plus p of x into y is equal to f of x. That should be our standard form. That should be our differential equation in hand. Okay, if it is not in the standard form, make it in the standard form by dividing it by the leading coefficient. Then what we do is we find the term called as the integrating factor. The integrating factor is nothing but e raised to integral p of x dx. That is actually the solution of the homogeneous equation. So you will find the integrating factor, that is if for short. If will be equal to e raised to integral p of x dx. So once you get this value, the solution will be as follows, that is y into integrating factor is equal to integral of integrating factor into f of x, okay, plus the constant, that is the integrating constant. Okay, so that is the solution. So from this we can find what's the value of y. Y will be equal to integral 1 by integrating factor into integral of integrating factor into f of x plus f of x dx plus the constant. So once the differential equation is in the separable form, is in the standard form, we will be able to determine what is p of x, and once we know what is p of x, we can determine the integrating factor, and once we know the integrating factor, we can find the solution. That will be y into integrating factor will be equal to integral of integrating factor into the function f of x into dx plus c. Okay, so this is the main steps involved in the in determining the solution of the differential equation. So let's just see an example which is given in your textbook. So example 1, we are asked to solve dy by dx minus 3y is equal to 6, right? So this is a simple differential equation and it is already in the standard form, as you can see. So from this, what will be p of y, p of x? P of x will be nothing but minus 3, right? Not 3y, minus 3y will not come. The standard form is dy by dx plus p of x into y is equal to f of x. So here p of x is nothing but minus 3. So p of x is minus 3 means what will be the integrating factor? E raised to integral minus 3 into dx. That is integral of minus 3 is minus 3x. So the integrating factor is e raised to minus 3x. Okay, so once we know the integrating factor, we can determine the solution. That is the solution will be y into, so here they have done this, it is the same thing. The solution will be y into integrating factor, that is e raised to minus 3x into y will be equal to integral of, what is f of x? F of x is 6 into e raised to minus 3x. What is the integral of e raised to minus 3x? That will be e raised to minus 3x by 3, minus 3 by minus 3. So that will be minus 3 and 6 will get cancelled, we will get minus 2. So minus 2 into e raised to minus 3x plus c. This is the differential equation. So here they have written like substituting the value, substituting the integrating factor and making it in this form. So it is better just stick on to it. The solution is y into integrating factor is equal to integral of integrating factor into f of x dx plus the integrating constant. So no confusion over there. Okay, so that is the way to solve this linear differential equation. Then we have something about the integrating constant of integration that we have stated, like in the previous lecture also we had discussed about it, that this constants can be combined to form a particular. So here if you see, if you have to determine y will be nothing but minus 2 into e raised to minus 3x divided by e raised to minus 3x, so that will get cancelled, plus c divided by e raised to minus 3x, so that is nothing but c into e raised to 3x. Okay, so that is about the constant of integration. And the next we shall do another example which gives us what is the general solution. So here you can see, if you see in the first example we had the solution was minus 2 plus c into e raised to 3x. So depending upon c, the solution can vary. So that is not a particular solution, it is a general solution. Okay, so here again we have another differential equation, that is example 2, x into dy by dx minus 4y equal to x raised to 6 into e raised to x. So first what we'll do, we'll make it into standard form. This is not in the standard form because there is x here. So I'm going to divide this by x. So I'll get dy by dx minus 4 by x into y will be equal to dividing by x, 1x gets cancelled, so x raised to 5 into e raised to x. Okay, so here what is p of x? P of x is nothing but minus 4 by x. Okay, So the integrating factor will be e raised to integral of minus 4 by x dx. So that is minus integral of dx by x, that is log x. So e raised to minus 4 log x. So minus 4 is this is equal to e raised to log x raised to minus 4. So this is nothing but a raised to log means it will be equal to the variable. So this is equal to x raised to minus 4. Okay, this is the basic identity of logarithm. So the integrating factor is coming out to be x raised to minus 4. So once we know the integrating factor, how do we find the solution? The solution will be x raised to minus 4 into y will be equal to integral of x raised to minus 4 into x raised to 5 into e raised to x. So x raised to minus 4 into x raised to 5 means it is the remaining term will be x into e raised to x. So the integration of x into e raised to x. So what is the integration of x into e raised to x? Integration of x into e raised to x is nothing but the value will be x into e raised to x minus e raised to x plus the constant c. Okay, so we have x raised to minus 4, which is the integrating factor, into y is equal to x into e raised to x minus e raised to x plus c. That is obtained by integrating x into e raised to x. Okay, or if you have to find y is nothing but y is equal to x raised to 5. I just have to take x raised to remove x raised to minus 4 from here, so I can do it by multiplying it by x raised to 4 on both the sides, right? So I get x raised to 5 into e raised to x minus x raised to 4 e raised to x plus c into x raised to 4. So I hope you are getting the idea how to solve the standard form of linear equation. Okay, if the given differential equation is in the linear form, linear is linear and the first order, then we can easily solve this by using the integrating factor. So this portion, I think it's better you just skip it out from your mind. That is actually the part of the derivation. So just skip that thing out of mind. Once you get the integrating factor, the solution is nothing but y into integrating factor is equal to integral of integrating factor into f of x. Okay, so you just have to integrate it, and if you have to determine y, just multiply divided by the integrating factor on both the sides. Now we are again coming to the concept of singular points and all. So that's what I had mentioned. When we are converting it into standard form, you have to keep in mind that a1 of x, that is the term in the denominator, must be non-zero, right? So if we consider a singular point, it will be the point where a1 of x is 0 clearly. So you can see we are asked to find the general solution of x square minus 9 dy by dx plus xy is equal to 0. So this is not in the standard form. So once we write in the standard form, what do we get? We get dy by dx plus x by x square minus 9 into y is equal to 0 by whatever it is, 0 itself. So here you can see p of x is nothing but x by x square minus 9, right? P of x is x by x square minus 9. So here when x is 3 or minus 3, what do we get? The function is discontinuous. So we will be dealing with the solution only in the interval between 3 and minus 3. Okay, which does not involve these variables. Okay, so on the first and third interval, on these intervals, we shall find the remaining is same. How to determine? The general solution is same. We just have to find what will be the integrating factor. Integrating factor will be e raised to integral of x by x square minus 9 dx. Okay, so that is I will have to do substitution method here. How to integrate x by x square minus 9? I'll put u is equal to x square minus 9. So du will be 2x. So x and x will get cancelled. So I'll get 1 by 2 into u into du. That will be again log u, that is x square minus 9. So this will be equal to e raised to 1 by 2 log of x square minus 9. That is nothing but square root of x square minus 9. Right? This is equal to e raised to log x square minus 1, x square minus 9 whole raised to 1 by 2. So that is equal to root of x square minus 9. So what will be the general solution? General solution will be y into root of x square minus 9 will be equal to, this is homogeneous, so this is actually the solution. So integral of 0 is 0 plus c. Okay, so this is how we solve the differential equation. And x equal to 3 and x equal to minus 3 in this case are singular points, so we won't be able to determine the value of y at these points, but all other remaining intervals we will be able to determine the solution. Now we shall just see one more initial value problem. Okay, the initial value problem is it's just simple. It's just, so far as we have discussed, we have seen that every solution is containing the term c, right? The constant of integration. So depending upon c we get different solutions. So in which interval is c, corresponding to that we get different solutions in different intervals. So this is another initial value problem. So in this initial value problem we will be given an initial value, that is y of 0 is 4. So we will be able to determine the integrating constant. So let's just see. We are asked to solve dy by dx plus y is equal to x. This is again in standard form. So what is here? P of x is equal to 1. So what will be our integrating factor? Integrating factor will be e raised to integral of 1 into dx, that is nothing but e raised to x itself. So the solution will be y into e raised to x will be equal to integral of x into e raised to x plus c. So what is the integral of x into e raised to x? X e raised to x minus e raised to x plus c. Okay, so this is our general form. So if I divide by e raised to x, I get y is equal to x minus 1 plus c into e raised to minus x, right? So this is the final solution. Now we can determine the value of c. How? Y of 0 is 4, that is when x is 0 the value of y is 4. Okay, so put x is equal to 0 in this equation. So this will be 0 minus 1 plus c into e raised to 0. E raised to 0 is nothing but 1. So we get c minus 1 is equal to 4. That is c is equal to 4 plus 1, which is 5. So the general solution, or the particular solution of this initial value is nothing but y is equal to x minus 1 plus 5 into e raised to minus x. So these are the few examples which are given in your textbook. There is just two more small topics which are left in this section, which we'll be doing in the next lecture. So in this lecture I want you guys to focus on the method of solving a linear first order differential equation. First step, convert it into the standard form. Second step, find the integrating factor. Third step, the solution is nothing but integrating factor into y is equal to integral of integrating factor into f of x plus the integrating constant. So keep this in mind. We shall be doing some problems related to it, the same thing. So that's it for today's session. Thank you.